All right, guys, let's talk about tectonic plates. So the idea that the Earth constantly changed or recycled itself was not always believed. In fact, it was not until the 1960s when geologists and scientists alike started to believe in the idea of continental drift. Continental drift was first proposed by a German meteorologist slash geophysicist named Alfred Wegener in 1912 when he noticed how the continents could fit together like puzzle pieces. He proposed that the land masses were actually interlocked together to form a supercontinent that you guys may remember called Pangaea. And Pangaea literally translates to all land. So despite Pangaea being discredited when Wegener proposed it, he was actually onto something. Some other pieces of evidence that Wegener suggested were that there were similar landforms or geologic units across continents. For instance, the Appalachian Mountains in the eastern United States and the Caledonian Mountains in the United Kingdom and Scandinavia are similarly aged mountain belts. That suggests that they may have been connected at some point. Remember, to find the relative age of rocks, we can analyze their rock sequences, and Wegener found that rock sequences found in eastern South America and western Africa that are similar despite being on opposite sides of the ocean proved or suggested that these rocks may have been together at some point. Finally, another piece of evidence that Wegener proposed that Pangaea existed was that there was the presence of fossils on continents separated by oceans, and that certain organisms only existed on one continent. So for instance, like kangaroos, they only exist in Australia. So in order for them to be stuck there, they must have migrated, and as the land started to separate and the oceans appeared, they had to get trapped. Now, despite this evidence seeming to be strong for you and me, Wegener failed to propose the mechanism for how the Earth transformed from Pangaea to what it is today. Once geophysicists and geologists began to utilize bathymetry, or the measuring of the depth of the ocean floor, support for the theory of tectonic plates began to arise. Now, again, this took decades for this to actually happen. Here is an image that shows the age of the oceanic lithosphere. The lithosphere, if you remember, contains both the crust and the uppermost portion of the mantle. Wherever you see red, the lithosphere is newer, fresh lithosphere. Wherever you see the purple, that is older oceanic lithosphere. You can see lots of activity in the Pacific Ocean, which is home to the Ring of Fire, named after the volcanoes that line the perimeter of the Pacific. Also, you can see the activity in the Atlantic. Here is what we call the Mid-Atlantic Ridge, which forms from a mechanism called seafloor spreading. If you watch the GIF or GIF to the right, you can see the process of seafloor spreading. That is one of the mechanisms for tectonic plate movement. The ocean floor is spreading apart and magma begins to rise, which forms these ridges. These ridges actually provide us with some really cool clues about our magnetic field too. The ridges have changed directional orientation over time, indicating that our magnetic poles have changed. South was north and the north was the south at one point in time. Where seafloor spreading creates new crust, subduction is where crust is destroyed. Sub meaning below, and duct, which means to lead below. Remember that the denser you are, the further you sink. So when two plates collide together, even if one plate is only 0.001 grams per milliliter more dense, it will subduct into the ground. So that's why typically you'll see oceanic crust, which is more dense, subducting when it collides with continental crust. That leads us to the types of interactions tectonic plates have. The first type is called a boundary. There are three boundaries. The first boundary is the convergent boundary. Con meaning together, and verge meaning turn or bend. Bend together. There are three flavors of convergent boundary. The first one is the ocean-ocean interaction. When oceanic plates collide together, their collisions result in subduction, which leads to magma escaping from the ground and forming volcanoes and ocean island arcs along these tectonic plates. So for example, the Ryukyu Islands in Japan are an example of this type of interaction. Or you can look at the Aleutian Islands in Alaska that are a little more closer to home. Those are also considered island arcs that have formed from this type of interaction. Now remember what I said. Even though oceanic plates are the same, just because there is a minuscule difference in their density, whichever one is denser is going to subduct into the ground. The second type of tectonic plate interaction is the ocean-continental interaction. Now, these occur when the oceanic lithosphere collides with continental lithosphere. Now, again, oceanic lithosphere is more dense than continental lithosphere, so subduction of the oceanic lithosphere occurs, and this results in even more volcanoes and mountain ranges forming along the interaction lines. So an example of this would be the Andes Mountains in South America forming as a result of this type of interaction. Now, our third and final type of convergent boundary is a continental-continental interaction. So this is two continental lithospheric plates colliding together. Now, this results in really large mountains. Since the continental crust has more depth, there usually aren't volcanoes or subduction that occurs. Now, it still happens in a small amount, but there isn't as much. So typically what you're going to see are some really big folded mountains that occur. And a really good flagship example of this is, as you may have guessed, the Himalayan mountains. The second type of interaction is the divergent boundary. Di meaning apart, and verge, again, meaning to bend apart. These boundaries indicate separation between plates. This occurs between two ocean plates and two continental plates. So an ocean-ocean divergence is basically sea floor spreading. So for instance, as I mentioned previously, the Mid-Atlantic Ridge, where there's a big division right in the middle of the Atlantic Ocean. The second type is the continental-continental divergence, and this is the reason why Australia is an island and why South America is no longer connected to Africa. A current example is the expansion of the Red Sea as a result of Saudi Arabia and northeastern Africa separating. As millions of years pass, we can expect these regions to be distant neighbors. The final type of boundary interaction is called a transform boundary. This type of boundary is different in the sense that the plates are not being created nor destroyed at this boundary. Instead, they are simply sliding past one another and changing the look of the Earth. An example of a transform boundary is the San Andreas Fault formed between the Pacific and North American plate that is near Los Angeles and San Francisco, California. Now, you guys always recall that California has lots of earthquakes. And in fact, there are over 30 earthquakes every day in Los Angeles. Yeah, that's crazy, right? But because they are so low in magnitude, residents don't even realize that they're happening. Now, occasionally you do get those big earthquakes, but for the most part, they are really small. Same thing for San Francisco. Now, while they don't have nearly as many as LA, surprisingly, they'll average about one earthquake a day. I think last year they had 380 or so earthquakes, so averaging a little bit more than one per day. Again, these earthquakes are usually really small. Occasionally they'll have a larger one in magnitude, but typically they are pretty small and people don't really notice them. The next type of tectonic interaction is called a trench. Maybe you're familiar with the Mariana Trench, the lowest elevation on the Earth. It is about 7 miles below sea level. In comparison, Mount Everest is only 5.5 miles tall. You could literally invert Mount Everest and dunk it into the Mariana Trench, and you'd still have space to spare. Can you believe that? Like, it's that deep compared to how tall the tallest point is on the Earth. So trenches like this form from the subduction of an oceanic lithospheric plate. As you recall, this will form volcanoes like a shaken soda can, or maybe even like a pimple. The process of subduction pushes magma out of the ground and onto the continental crust. So the process of making these trenches actually produce volcanoes. And just like I said, this pimple or like a soda can, you have this eruption as a result of this trench getting deeper and deeper and deeper. The final type of tectonic interaction I'm going to introduce is mountain formation. I'm going to focus on just two types here. The first type is called a folded mountain. Folded mountains form when two continental plates collide together and force sedimentary rock upwards to a common center. These rocks begin to change or metamorphose as a result of this tectonic plate interaction. Some examples include the Swiss Alps or the Himalayan mountains, as I mentioned previously. The newer layers are called the syncline, while the older layers of these folded mountains are called the anticline. You can see on the picture to the right, the green represents the syncline and the tan represents the anticline. Now, the last and final mountain type that I'm going to be introducing is called the fault block mountain. This mountain type contains two familiar terms: fault, which simply means large crack in the earth, and block, meaning large solid piece. These mountains form as a result of faults or cracks forming between a geologic formation. Then, as these tectonic plates collide together, it forces up one block while the other two sink. Imagine grabbing a slippery bar of soap. You know, like in the cartoons, you know, they grab the soap with both hands and then you grip it too tightly and the soap jumps right out of your hands or down below your hands. So imagine the soap as it slips up or slips down. Those are called the horsts. Okay, the horst represents the regions that rise up, and then the grabens represent the parts that fall. So in this case, if the soap is jumping out of your hands, the soap jumping out of your hands is the horst, and your hands represents the grabens. All right, guys. Hopefully that was helpful. Until next time, I'll catch you later.